Over the past year, we've been doing a lot of water sampling in the bogs to figure out where the hot spots of nitrogen are so that we can be really intentional about where we place the bioreactors. We're putting in 3 bioreactors this week. We've been spending the week clearing out the ditches of extra muck and just prepping them for this installation. We're building off of the original bioreactors by adding in a new component, and that's the biochar. So biochar has a lot of unique properties that should sort of supercharge nitrogen removal. So it works with the wood chips. The wood chips provide the carbon source for the microbes, and the biochar is just a really absorbent material where pollutants will stick to the surface area of that biochar surface.
It's known from research in agricultural systems and other systems that biochar has some really unique and desirable properties, one of which is its ability to remove nutrients from water sources and therefore clean the water sources. So we wanted to see if adding that to a wood chip mixture could augment the nutrient removal and cleaning properties of these bioreactors, and that was basically what motivated and informed the design for this second set of reactors that we'll be installing.
This project is funded by the Southeast New England program, which is supported by the Environmental Protection Agency and administered by Restore America's Estuaries.
From the first 2 bioreactors, so the large 40-foot one and the mini reactor, as we called it, we learned that the substrate really matters, what size wood chips, but also the fact that there's a lot of biological activity in these ditches that can end up clogging the bioreactor. And so these new bioreactors going into today takes into account the new wood chips, as well as putting the bioreactors at the head of the ditches, so there's really no upstream side to carry things into the bioreactor and clog it. The water in these ditches are so full of nutrients that even though it's early in the season, we're already seeing algae blooms in all of them. It's especially notable near our bioreactors. You can see the problem and what we're trying to do to solve it. Mount Holyoke has been a part of our team the entire time with the large bioreactor and also the smaller one. And we've been working together, and they've been able to incorporate the lessons learned from the first 2 reactors into today's installation.
Well, we have lessons that we have learned, and we're hoping to learn a lot more. We're learning quite a bit about the differences in what's in the water among the different ditches. What is the difference in the species of nitrogen that they have, the species of phosphorus they have? What is that water's quality? And so the first bioreactor and the second bioreactor are helping us look at all the different ditches that have bioreactors above and below the existing bioreactors, as well as within them, to see, are we seeing any changes in water quality emerge at this early stage.
Monitoring for these projects is key. We want to make sure that we're treating the nitrate in the water, but we also want to make sure that we're not harming the environment in our effort to heal the environment. In Cranberry Bog restorations, the current protocol is to fill all the ditches with sand, and we hope to take advantage of the wood chip's ability to respirate nitrate in the water and incorporate this strategy into Cranberry Bog restorations.